So here's some help with question number 6 from your homework. I'm going to do this a little differently than it's done in the back of the book, just to show you that there is a method for doing this. You don't always have to take a shortcut. So I'm going to take the long and tedious route to get there. Now I'll warn you in advance, I haven't tried this question first. So you'll maybe get to see me run into roadblocks and not be certain along the way, get stuck at certain points. I can see this question taking me a long time to solve, but that as long as you just take your time with it, that it's possible. So I'm going to change everything to sine and cosine. So instead of tangent, I'm going to write sine over cosine. And what's inside the sine and the cosine will be the same as what's inside the tangent, 90 minus a. I'll change this. I'll do the same for a tangent of 180 minus a. Change it to sine over cosine. And I'll change secant to 1 over cosine. So I'll change cosecant to 1 over sine. And then sine can just stay the same. And cosecant can change over to 1 over sine. Oh, look, that's nice. Already I can see that I've got sine 90 minus b and 1 over sine 90 minus b. Those will cancel. So already I can see that some things are canceling. So now I'm going to use my addition and subtraction identities to expand each of these terms. So if I do sine of a difference between two values, that's the same as sine cos minus cosine, first angle, second angle, first angle, second angle. So instead of sine 90 minus a, I'm going to write sine 90 cos a, yeah, that's right, minus cos 90 sine a. So I've expanded the yellow one. Now I'm going to expand the denominator. If I subtract a cosine in brackets, let me use x and y because there's an a in my b spot at the bottom, which makes it kind of confusing. So if I'm subtracting cosines, it's cos cos, sine sine. The sign in the middle changes, so instead of minus I have plus, and then I go first angle, second angle, first angle, second angle. So let me do that down here. So I've got cos 90 cos a plus sine 90 sine a. Now I'll do that again with 180. Sine 180 cos a minus cos 180 sine a. And I'll do that with my denominator. That'll be cos cos plus sine sine. So cos cos plus sine sine. And then I have 1 over cosine still. So these are all terms here. And then I've got plus 1 over sine b. Whew, that was time consuming. And now I'm going to try to simplify using my special angles. So I know 90 degrees is up here. Cosine of 90 degrees would be the x-coordinate at that point. So the x-coordinate is 0. And sine of 90 degrees would be the y-coordinate at that point. So sine of 90 is 1. So cosine of 90 becomes the number 0. So all of this actually disappears. Cosine of 90 becomes 0, so that's gone. And sine of 90 becomes the number 1. Sine of 90 becomes 1. Okay, so now this simplifies, and I'll write it down here. The yellow part is just cos a, and the blue part is just sine a. That's a lot simpler. And I'll do the same thing for the 180s. When I'm at 180, the cosine value is my x-coordinate, which is negative 1. So instead of cosine 180, I'll write negative 1. My sine coordinate is sine value is my y-coordinate, which is 0. So instead of sine 180, I have 0, which makes 0 times cosine A is all 0. And 0 times sine A is all 0. So here I've got negative 1 sine A. So that'll be positive sine A. On the bottom I've got negative cosine A. So already it's becoming much simpler. And then I have 1 over cosine A plus 1 over sine B. So now I can cancel in this left-hand side. Sine divided by sine is 1. Cos divided by cos is 1. So I get still a negative sign. 1 over negative cos A plus 1 over sine B. Now I can change that back into cosecant and secant. So that would be negative secant A plus cosecant B. Voila. That was only 6 minutes. That's not so bad. So now for part D, I'll do the same thing. I'll just use sine and cosine for everything. So let me write that where I've got some more space on the right-hand side here. So secant, cosecant. Secant and cosecant. Now 180 minus A, 270 minus A. And then I have minus cotangent tan 630, 540. Minus cotangent tan 630, 540. Plus A minus A. Okay, so first things first, I'll change everything to sine and cosine. So instead of secant, I'll write 1 over cosine 180 minus A. And instead of cosecant, I'll write 1 over sine 270 minus A. Cotangent becomes cosine over sine, and inside of the brackets stays the same. And technically I should be writing degree signs beside all these angles, otherwise they're in radians, but I'm a little lazy right now. So tangent is sine, and the inside of the bracket stays the same over cosine. And these should be plus. Okay. Now, I'm going to use my sine and cosine identities to expand each of these 1, 2, 3, 4, 5, 6 different expressions. This is going to get very, very long. So, cosine is, let me write really small so it'll fit. It's cos plus sine. Sine. Sine, on the other hand, is sine cos minus cosine. So the nice thing about the sine identity is that the sign in the middle stays the same, whereas the cosine sign changes. Okay, so there's the first two terms. Already I've used up more than half my page. Minus, oh boy, cosine is cos, change the sign, minus sine, whereas sine is sine, cos, don't change the sign, plus cos, sine. And then that's all multiplied by the next fraction, which will be sine cos, and I don't change the sign, so minus cos sine. And in the denominator, I have cos, minus sine sine. Phew! Now, using special angles, a lot of these things will cancel again. So let me figure out these 180s. So 180 is over here. Cosine is the x-coordinate, which is -1. And sine is the y-coordinate. So instead of cosine, I've got -1. Instead of sine, I have 0. 270 is down here at 0, -1. So my x-coordinate is my cosine value. My y-coordinate is my sine value. So x-coordinate is 0. So cosine becomes 0, which means everything attached to that term becomes 0. And sine is -1. Moving on to the next term. 630. How much is that? Well, here's 360. And then 720. And if I take away 100, take away 90. There we go. 720 minus 90 is 630. So that's the same as 270. It's still the point 0, -1. It still has the same cosine and sine value as the last one. So cosine is 0. So instead of cosine, I'll write 0. Everything that's attached to cosine 630 will cancel off. And sine becomes -1. And then the last one, 540. Here's 360 plus 90 is 450 plus 90 is 540. So 540 is actually the same as 180. It's the same, they're coterminal angles. So my x-coordinate is -1, y is 0. So my cosine is -1. So all the cosines become -1. And the sines become 0, which means everything attached to that term will become 0. So now it's going to be much simpler. Just have to synthesize all this information. I still have 1 over here. I've got a negative sign in front of my cosine, so just negative cosine A. Same thing for my second term. I just have a negative with the cosine. So negative cosine A. So there's my first two fractions. So simple. For my second two, the top, I just have negative, which is positive, sine A. So positive sine A. And then negative cosine A on the bottom. And that's ignoring the fact that I also have a negative sign at the front. I'll just keep that there. So the second fraction has negative, again, which is positive, and sine A. So positive sine A. And the bottom is negative cos A. So I get 1 over negative cos A times negative cos A is positive cosine squared A minus sine squared A. Negative times negative is positive cosine squared A. So now I have a common denominator. I can just subtract the numerators. And because cos squared plus sine squared is 1, 1 minus sine squared is cos squared. Wow! All of that just became the number 1. How amazing is that?